Alright, so this is going to be our last notes for this chapter. This chapter is called Perpendiculars and Distance. And it's going to be talking about how do you find the distance between a specific point and a line. And an example here, you can see this, if this was like a pendulum or some kind of ball hanging on a string, okay, you would want to say, you know, what is the distance between this ball to the ground, and you would see it changes. So if you move the ball over here, the distance increases, right? And if you move it over here, the distance is even greater, okay? And really, the closest you can get to the line is when the ball and the string are straight up and down and are perpendicular, okay? So we use that kind of idea to help us solve some of these problems. If we have a point not on a line, and a line, how far away is that point from the line? You can see the words here. It says, so the distance between a line and a point not on the line, and this is an example of that, A and B, and then C. How do we figure that out? Well, it's the length of the segment perpendicular to the line. So if we're going to draw a line, right, we want to find out the distance. We'd want to make it perpendicular at 90 degrees, and that line, this line right here, that would tell us the distance from that point to the line. We wouldn't want to come out here, right, because we could have all kinds of different distances if we were not perpendicular. So this is defined by the fact that it is perpendicular. And we have a postulate that goes with this, and this postulate says, so if given a line and a point not on the line, there exists exactly one line through the point that is perpendicular to the given line. So there can only be one line that can satisfy this perpendicular condition up here. So keeping that postulate in mind, we may look at an example here and see if we can use this idea and some other things we know about slope and some other things we've covered in this chapter, and see if we can match it all up. There's going to be something with systems of equations, and hopefully you remember that from your Algebra 1. I'll go over it really quickly here, and you can ask me about it tomorrow if you're not sure how to do it. Okay, but example 1 here says, so we have line L, and it contains points at -5 and 3, and 4 and -6. So it says find the distance between the line L and point 2, 4. So we have points, and we could graph them out, and that may make sense. So let me pause this here a minute, and I'll make a quick graph. So if we take these numbers and we graph them out here, this line L and a point, we'll just call it P, this is kind of what the graph looks like. So we have this line L, and we want to say what is the distance here between P and this line. It's going to have to be a perpendicular line. We have to figure that out. So if we continue, the first step is to solve for the slope of the line. So if we look at that, we just plug in. We're going to use our points that we got from above, -5, 3, 4, -6. Plug it into the slope formula, do all the math, and we get a slope of -1. We're going to then use this first step to rewrite this line in the slope-intercept form. You might say, well, why are we doing that? Well, that's actually going to help us find out the point where these two lines meet, and we're going to do a systems of equations when we get there. So what we need to do is figure out these two equations for these lines, and then we'll use them to figure out that point where they meet. And I'll explain that here to you in just a minute. So that we did the first step, we have the slope, it's -1. We then rewrite the slope in the slope-intercept form for line L. So we have y equals mx plus b. We know the slope is -1. That's going to go where the m is. And we have 4. That's going to be our x. That's going to go next to the slope. And then we're going to have -6 goes with the y. So we plug all that in. We end up with -6 equals -1 times 4 plus b. Our problem is we don't have the intercept. So then, but we have everything else, we can then solve for the intercept. So we do all the math, and we come up with the fact that the slope, the intercept for this is -2. We can then rewrite the equation y equals, the slope is -1, so we just need a negative sign. Then we have the x, and then the y-intercept b is 2. So that's our equation, slope-intercept form for line L. We then do the next step. We then write an equation for the line perpendicular to L. And we'll call that line W. We do that by using the same form. Okay, so the slope-intercept form. So we're going to have y equals mx plus b. And we have one point from that line. That's all we need. And we can plug in what we have again, just like we did with the last one. So then we have, this is going to be our slope, right? It's going to be 1, okay? And then, and if you remember, the slope is 1 because this line is perpendicular, so it's going to be the opposite slope, right? So it's not -1 like our last one. It's actually perpendicular, so it's going to be +1 this time. And then we have the points. We don't have b. We're going to solve for that. We plug in 4 for y, 1 or 2 for the x, 1 for the slope, and then we have b left. We then solve for it. We have 4 equals 2 plus b. We minus 2 from each side, and we get b equals 2. We then have an equation, y equals x plus 2. Okay? So then we want to look for where do these lines intersect, because then once we get that point, we can really start moving on this, figuring out the exact length. Okay? So our next step is to then, to solve these. So we ended up with an equation for line W. We had an equation for line L. We then solve using a system of equations. Okay? And we use something called elimination. And we're looking for the intersection point. Okay? And this is going to help us find that. So we just take each of the equations, line L, the slope-intercept form, and line W, that slope-intercept form, and we add them to each other. And we see what we get. And this is from earlier in algebra. You should have had this. If not, we can talk about it. So then we end up with y plus y is 2y. These x's cancel, and then these cancel. So we get 2y equals 0. Divide by 2, right, we get y equals 0. Okay, so then we have the y point, right, for W. That gives us y equals 0, where these intersect. And then we then plug that into the equation that we got up here, this y equals x plus 2. And then we can solve that using plugging in the 0 in for y, and then we have 0 equals x plus 2. We solve for the x, and it's -2. We then have our point where they cross, -2 and 0. Okay. So then, if we want to know the distance between those 2 points then, because we have the point that we started with up here, right? 2 and 4. And then we have this new point that we just calculated. If we go back to it, which is -2 and 0. And we could even put that onto our thing here, right? So -2 and 0 would actually be right here, right? So we know if we drew a line in there, it should be perpendicular. If we draw a line in there, okay, it should be perpendicular. And this is -2, 0. We have those 2 points now, and we can now use them to figure out what the distance between them are. Okay? So we're going to use that distance formula that we used a little bit ago. And it's x2 minus x1 squared plus y2 minus y1 squared, and then we do the square root of the whole thing. We use these points right here, 2 and 4 for P, and we'll call this new point Q. Okay. And we will then plug in numbers. So -2, we plug in all our numbers we have. In the end, when we do all the math, we end up with the square root of 32. If we just figure exactly what that is, it's 5.66 units, or we could just say the square root of 32 is the distance. Okay? So that's how you solve that problem. I'm going to show you something a little bit different tomorrow and add something to this in class. It won't take very long, that's our notes on perpendiculars and distance. Go ahead and add these to your notebook. We'll add something shorter tomorrow, and then we'll do some practice problems, and then you can work on this in class. Hope this makes sense to you. Thanks.